Okay, so 1/2 plus 1/3. And we can represent this using Cuisenaire rods. So here's 1/2, and here is 1/3. So the very first step would be to find a common denominator, because we need to talk about fractions that are the same unit to get our answer. So remember, if the denominators are different, we have to talk about fractions that are in the same unit to get our answer in fraction form. And the way that we can figure out what our common denominator is by using rod trains. So the first thing that I would have to do, I would have to line up the denominators, or the wholes. So the wholes represent the equal pieces. So for example, for 1/3, the whole is divided into 3 equal pieces, and out of those 3 equal pieces, 1/3, one unit is the shaded region. So for the 3 equal pieces, they all equal 1/3, making the whole. So if I'm going to start lining up our denominators, I'm going to start with 3, and I'm going to go by 2's. So now I'm doing our other denominator, and I can see that now they are the same length. So I'm going to add the numerator in to make it look a little neater. So I have 3 copies of 1/2 and 2 copies of 1/3. So now that they are the same length, we can see that I needed 3 copies of 1/2 and I needed 2 copies of 1/3. So we can think about these fractions related, and we can talk about them in terms of 1/6. So on paper, this is what it would look like. So here's 1/2, and here is 1/3. I needed 3 copies of 1/2, so that's gonna give me 3/6. And I needed 2 copies of 1/3, so that gives me 2/6. And this is why we can talk about them in terms of 1/6, because our common denominator is 6. So the numerator is the number of parts in a whole, and the denominator is the equal parts in a whole. So this is why we add the numerators. So for 3/6, there's 3 in the quantity of 3/6, and for 2/6, there's 2 in the quantity. So 2 copies of 1/6, or for 3/6, 3 copies of 1/6. So these are now our equivalent fractions: 3/6 plus 2/6. And we can add these because we have a common denominator now. So moving on to adding, we're going to add our numerators. So 3 plus 2 gives us 5, and our answer would be 5/6. And this is what it would look like with our Cuisenaire rods. So we're going to make our equivalent fractions. Three-sixths and 2/6 gives us 5/6. So 5/6 is 5 copies of 1/6. Now moving on to our other equations, like 2/3 minus 1/2, we're going to repeat the same process. So here we have 2/3 and our second fraction is 1/2. This time we're going to be subtracting 1/2 from 2/3, but we still have to go through the same process of finding a common denominator because we need to talk about them in the same unit to get our answer in fraction form. So again, we can make the Rotrins using our wholes, our denominators. So once again, we can see that they line up, and we can add our numerators again. So that gives us 3 copies of 1/2 and 2 copies of 2/3, and they are the same length. So this gives us our equivalent fractions of our common denominator was 6. So this gives us our equivalent fractions of 4/6 and 3/6. So now that we have our common denominator and our equivalent fractions again, we can just go straight to subtracting them. So 4/6 minus 3/6 equals 1/6 in its most simplified form. So our equivalent fractions are related because we can talk about them in terms of 1/6. And with Cuisenaire rods, this is what it would look like. So we have 4/6 and we have 3/6. And then we finally subtract them, we get 1/6. Which is just one copy, one shaded unit of 6 equal pieces of 1/6. So if we wanted to do 2/3 plus 1/2, the same fractions we just have, we would do it the same exact way again. So here we have 2/3 and we have 1/2. So again, we need to find our common denominator even though we already know it, and we're going to line up our whole pieces. So that doesn't add up, that's not equal, it's not the same length, we still have to add more. So I'm going to pull it down now to add our numerators. So we needed 2 copies of 2/3, and we needed 3 copies of 1/2. On paper, this is what it would look like. So again, we needed 2 copies of 2/3 and 3 copies of 1/2. So that gives us 4/6, and that gives us 3/6. But this time we're going to be adding them, and these are our equivalent fractions, which we can talk about in terms of 1/6. Here we have 4 in the quantity in our numerator, and here we have 3 in the quantity in our numerator. So we're going to be adding our quantities, our numerators, and that gives us 7/6. And that's an improper fraction. We could also think about it as a mixed number, which would give us 1 and 1/6. So using Kuznets, this is what it would look like. So first let's show our equivalent fractions. So we have 3/6 right here. We have 3 copies of 1/2, which gives us the equivalent fraction of 3/6. And we have 2 copies of 2/3. And that gives us 4/6. So 4/6 plus 3/6 gives us 7/6. So 7/6, that's one more unit. That's one more unit of 1/6 out of our whole. So to represent that as a mixed number, we have 1 and 1/6. So we have one whole. Here's our whole. And we have our second piece. And this is shaded. This is our one whole, or one piece. And if each piece equals 1/6, and there's 1, 2, 3, 4, 5, there's 6 equal pieces, only one of them is going to be shaded. So that gives us 1 and 1/6. So again, as part of our reflection for part C, we need to find a common denominator because we need to talk about our fractions in the same unit to get our answer. So this is an important way to teach our students that finding the common denominator isn't just some rule, but it actually helps us do our fractions easier. And it helps us to find them in the same unit because we're not doing decimals, we're doing fractions. So to get 1/2 plus 1/3, or 2/3 minus 1/2, or 2/3 plus 1/2, we need to find our equivalent fractions first. We need to find our common denominator, which would be 1/6.